We are recording.
Okay, great. What did y'all teach in math this week?
Want to go ahead?
I mean, I'll go first. We just did counting, like adding up to 20. So a lot of it is based off. So like a lot of the I was able to use one of the strategies specifically was, you know, being able to use like concrete stuff is like, base 10 blocks or just cubes. Because a lot of the stuff that we do for math in there is very concrete. Like we have to physically show them like why does 10 plus 5 equal 15?
Right. Put out in their hands. Yeah, for sure. My week was weird. So we introduced place value, 5th grade place value. So that includes like powers of 10, multiplying, dividing, with decimals. And I'll talk about my lesson. That was a total failure on Monday. And then middle of the week we had to give our universal screener, which is through the same people that do milestones. It's a
I think I've got that. Yeah.
And so that was their first year doing that, and we had to spend like a whole lesson teaching them how to even use the tools and everything on there. That took an entire lesson. And then they took the test one of the days, and then Thursday my lesson went great. On place value, I tried to do concrete. I chose model with mathematics for the practice on Monday, and I'll go into more detail later, but that didn't go well. And then when we used it with a place value chart, which is also modeling, it's just not as it's not place value blocks in your hands. It went a lot better. And then yesterday, I wasn't even in school. I had a sub because I had another math training thing to go to. So kind of weird week for me.
Yeah.
Came to math. What about you, Livy?
We taught place value at the beginning of the year, and I didn't use the hands-on manipulatives, but they did like using the chart, seeing how it multiplied and divided. But we did expressions this week, and then multi-step word problems. Wow, that was struggling. Even we took a test on Friday, and I was like, remember when I ask you to write an expression, do not put an equal sign, do not solve it.
Right.
I was walking around, I'm like, erase that equal sign.
Yeah.
Heartbeat, you solve it. And then the multi-step, we did it for 2 days. The first day, it wasn't as bad because it would be like multiplication and then we would add. But then the second day we did it, they tried to use all like either 3 or 4 operations in one problem. That blew their minds.
It was like word problems, but with like order of operations.
Yes.
We had to make the expressions, not solve. Yeah.
And then we solved 2 days with the actual word problems, and then the first day was just expressions where we didn't have to solve.
Okay.
Yeah, anything word problems is so hard for kids.
Yes. Yeah. And I've noticed, I'll talk about this later, and I'll actually ask you this later. Understanding what the remainder actually means. Like, there was one question where it was like, talking about buses and going to a field trip, they could not understand why if you had 11 students left over, why you would have to do like an entire another bus versus if you're talking about change and how it would just be like, okay, everybody gets $1.25 and with that remainder of 25. I don't know. That concept was like,
yeah, you would think with it being real life based, like why would you need another bus? Because you want to leave 11 kids back,
Yes.
That's why the answer doesn't have a remainder in it. You take the remainder and you take the whole number of buses and you just bump it up one more for those 11 extra kids. You would think that making it relatable to real life, they would make more sense, but it's got to be the way that they learn remainders. I think maybe in 4th grade, and it's so focused on division no longer goes in equally like they do in 3rd grade, but you actually have a remainder in 4th grade. And then kind of going further and saying, even though there is a remainder, if it's asking how many whole, then that number goes up one more. Yeah.
Yes. Yeah. We kind of talked about our struggles. Did we have any wins this week? Anything that went well for us?
Because I know we had to do we had to do the implementing thing. So I'm looking at that. So
yeah,
because
with my successes, what did I put for a success? I talked about Monday being a hot mess. I was like, yeah, we're going to try manipulatives, and it just confused them so bad. So the thing that confused them is, so they've used place value blocks before to represent ones, the rods for tens, the flats for hundreds, the cubes for thousands. But we tried to talk about relating it to thousandths and hundredths and fractions and decimals. And so I had them looking at a thousands cube, and talk about what fraction of the thousands cube would be a flat. So a flat is 100, so it'd be a tenth of
Yes.
the whole cube. They had to think of the whole thousands cube as one whole, like as if it was the one little. And it because, for one thing, I think decimal is confusing already for kids. And then all the previous understanding of flats, rods, cubes, thousands cubes, having it relate it to, even though it was supposed to be concrete, it seemed very abstract to them.
Yeah.
And so that was, I wrote under successes, but it wasn't. But I would say my Thursday lesson on place value, where we talked about the connection of, as the place values get larger, it's times 10 every time. And as it gets smaller, it's divide by 10 or a tenth of each one. So even just like on whiteboards, if I said, okay, I need to put a 7 in the 10,000s place, and then put a 7 that would have a value that is 1/10 of that, they would put it one space to the right. And so they did really well with that, which was surprising, because even though it's a simple concept, a lot of kids struggle with, they can do the times 10 as it gets larger, but they go backwards as things get smaller. Or if I go 2 spaces, so if I say something that is 100, the value of that spot's 100 times larger, instead of going just one spot, they have to go 2. Or if it's, instead of a tenth of it, it's 100th or 1,000th of it, having that many spaces. But the modeling with mathematics, but doing it with place value charts, where they had to draw in and actually physically move, did end up going a lot better than the actual manipulatives.
Yeah.
I'd say for me, like, my biggest win was, like, just because of the kids I work with, they do get very frustrated when they don't understand something. And so, like, they don't know how to, like, handle that frustration. So a big win was, like, when, instead of, like, one of the students, because a way that I did it was I just let my teacher, like, do the whole group, and then I just took a small group of students and taught it my way with them. And so, like, one of the students, instead of, like, him getting very, like, frustrated, like, when he didn't understand how to do it one way, he just used a different strategy. So, like, if you didn't know how to do it with, like, the blocks that we're using, I was like, okay, let's use the number line. He's like, oh, okay, like using that strategy, which was a big win for me. So I'm like,
it's good when they can be proud of themselves and see success, especially when they're so quick frustration.
Yes. Yeah. What grades do you work with? First through third? Is that right?
No, 3rd through 5th.
3rd through 5th.
Yeah. Okay. So, because we have kids with autism, Down syndrome, and so
they're older kids, but the concepts they're doing are younger.
Yeah, because we have higher kids, like, it's just like the ones that with autism basically are the higher ones, I think just because they have autism and the behavior, like, they're just they need the help. So, like, I would work with them and then a couple of other students.
Yeah. One of my successes was we did a lesson where I actually gave them the expression. So I would say, like, 3 times 5 in parentheses minus 4. And they enjoyed coming up with word problems for it. After we went over the vocabulary of, like, if it says in total, that's probably going to be adding or multiplying. And then if it says, like, shared equally, probably going to be division, or giving would be subtraction. And if I could redo the lesson, I think I would, like, allow them to walk around the room and do, like, on a piece of big paper, and allow them to do the word problem and then move and solve different word problems instead of being so, like, sedimentary.
Yeah.
Right? That's the word.
Yeah.
And I think that would help me bring in one of the mathematical practices where they get to kind of discuss their answers and thinking. So,
let's see.
One thing that's I apparently put a lot of struggles, not as many successes. It was just a rough week in general. Is so the end of last week, my kids took a test on volume. We were finally wrapping up
Nice.
volume, and we had to use the state provided test bank questions, just because, again, most exposure as possible to the people that make milestones. It's a struggle now, but I really think there's going to be successes in the future of just having these kids productively struggle this year. But see the questions the way it's going to look when the milestones come, instead of teaching it our own way and then be like, okay, we'll apply everything we learned, but in the way they do it. So I really do think it's going to pay off in the long run. But grading those things, God, I felt like a failure. Like, I had, out of my 2 classes, my homeroom class is a lot lower in math. And so there was, I would say, most of kids, I mean, I have to curve up. If anyone fails, I have to still curve it up to a 50, even if they got every single one wrong. Which is fine, because if you put a 0 in the grade book, it's going to like take down their grades so far. And I maybe had 4 pass the whole test. And then second period, it was more like half and half failed and half passed. But we sat down with the principal and we analyzed the data across the grade level and which questions on the test, just kind of look at the percentage. Was it was it the question itself? Did it make sense? How, deep of a DOK was it? But that was just rough, having to sit and grade those and go, oh, but no parents came back after I put it in the grade book being like, oh my gosh, can they retake it? Which I was prepared to be like, listen, it's a struggle now, but you're going to see benefits if we continue to work on these harder and deeper thinking questions.
How have you told your students that? Just that it's going to be hard, but just embrace it, because some of mine are doing that right now. They're just coming into 5th grade and it's like throwing all this stuff at them and they're like, this is hard, and I don't want them to stop trying.
Yeah, I think because we celebrate so much the successes when we get past something that's hard and people are getting it. And we just talk about related to working out, or if like a sport that you play, it's don't you feel so good when it's hard at first and it gets easier because you get better at it. And that we're just going to think a little deeper this year, and we're going to really work. I told them it's a goal for me. Like, one of these things I'm working on, and they know I'm in school, is really not jump into your rescue right away. And you don't feel ownership over your successes if I just tell you the way to get there. If I make you sit there and without a strategy, just like, how would you solve it? And just leave you to think for yourself, you really are going to feel so much more proud of yourself when you get to the answer. And if you don't get to the answer, you can still feel proud of yourself that you didn't sit there like a bump on a log and let me just tell you the steps through it. You took the time to adapt and really go, oh, how would I even start? Like, where do I start? Start drawing a picture. Like, I'm not letting any of them give up, and they've handled it pretty well, attitude wise. But yeah, we definitely talk about it a good bit, about that growth mindset. I'm not, that's a big focus in the school this year, is that power of yet. I don't get it, but if you give it some time, and push yourself, you will get there.
Yeah. I've seen one student in particular that I know that can do it, but if I ask anybody, like, if you need help, come to the back table, he's always there. And I'm like, I know you can do this on your own, but he's second guessing himself or X, Y, and Z. So that's why I asked that question.
Yeah, with him, because there's some that are just needier in general, and if you allow them to come get help whenever you offer it freely. And then you have some that need help and they refuse to. So sometimes you just say, so come to my table.
Yes.
And so you can work in partners, and so work by yourself. And you can change it up. It doesn't have to be the same kid. So he can still get that, attention, because it's probably partly an attention thing and partly is a confidence thing. If it sounds like you think he's getting it, but he doesn't think he's getting it. We dropped Hannah.
Yeah.
She'll pop back in.
Oh, she's calling me.
Okay. We've had some technical difficulties with our meeting. Okay. Do you want me to just put you on speaker? Yeah. Okay.
Good for the situation right now.
She said her computer just stopped working, so she's on speaker.
We've definitely had some technological difficulties. My meets wouldn't allow me to go in when Livy sent it, because she's the leader this week, and so I had to make my own meeting. So we're just going to do it this way. We're all here. We're still discussing.
Yes. Can you hear Hannah?
Yeah, I can hear you.
Okay.
Good.
I'll still try and make sure get my computer to start working, but just until then.
Yeah. All right. Are y'all good to move on to question 3?
Yes.
So it just asked.
The area you can improve in.
Oh,
yeah,
yes.
mathematical practices. So I made a note. I just wanted to add. I was so excited to like use manipulatives. I'm like, that's my goal this year. I don't use them enough in 5th grade for them to really get conceptual understanding. But my God, I don't know if you guys have a good strategy of how to not get them to be distracted by the manipulatives. If I have them working in groups, you got one kid building blocks out of your blocks instead of doing nothing mathematical. And I'm pretty good overall usually with expectations of being like, listen, we're using them for this purpose. If you can't, then you can do it on paper and draw the stuff and the other one can. But I don't know. I want to be able to use more manipulatives, but that was just an area that was a major struggle with them not wanting to goof off and play with them.
Yeah. Hannah, you probably use more manipulatives than me because I even put a question on asking you how you use manipulatives in 5th grade.
Yeah. So like we use block, like a lot of times we use games too, like, or we use blocks a lot, or like pictures for them, and we'll like do hand on hand with a lot of them, and we'll be like, okay, 1, 2, 3, and then we'll count. Okay, we're gonna add 5 more, and then count 1, and then count 5 with them, and then like, okay, now let's count all together. So now let's count all the blocks, and then we'll count both groups of the blocks.
I think it's different for Hannah because they do hand over hand, which is a pretty common strategy in special needs classrooms. And it's one because there's less of you and more teachers in the room. It's just like having 20 something kids, and I would say the majority are engaged in using the manipulatives the correct way. But
especially like when you're in a general education classroom, they're like the school is more focused on like they want the kids to test good, or like their grades are more like. Because like in my classroom, we're more so like, okay, just get them to like.
Yeah.
I feel like, all right, I'm good for 3 now. If you guys want to go into the practices.
Oh, how do you all divide? Because I don't remember ever being in there when y'all divided last year, but we divide like not using standard algorithm.
Right.
At first, we use partial quotient.
Yep.
And I was just wondering if that's how y'all did it or how you taught it.
Well, last year I did not do as much with 4th grade. They can't teach anything standard algorithm. In the 5th grade standards, you're allowed to, but if you teach them the tricks, then they're only going to continue to use that because it's faster.
Yes.
So we'll be teaching it. Let's see, we're finishing up place value and powers of 10. And then we fall break, and then we're going into measurement because it relates to powers of 10 and conversions and things. Then we go into multi-digit multiplication, and we'll do area model, partial product, and then standard algorithm. And then we do long division going into late October, early November when I'm looking at my plans right now and the pacing guide that we came up with. But we'll start with partial quotient. That's the main, partial quotient, base 10 blocks. So, and when I taught 4th grade, I made sure that when they're introduced to it, because in 3rd grade, they're really good about sharing equally. So taking those manipulatives of just single cubes or whatever and have 36 and divide it into 4 groups and just physically, and then they move to circles where they draw a circle and they, evenly give out until there's none left. And then that's also how they learn remainders. So if it doesn't go in equally, once you run out and you don't have enough to give back to each circle, then you off to the side, you have that many and that's your remainder. And you can do the exact same thing with larger numbers. And do it with the base 10 blocks if you have them, and then move to the drawings. It's just say the number is like 1,247 and you're putting it into 4 groups. You would start by giving out hundreds until you give out, and you draw them as just a square. A square would represent your flat. And that's all still very conceptual. But if you go into and you're supposed to do standard algorithm in 5th grade when you get to long division, but then if you don't get the conceptual, they don't really see the connection back to the progression of younger grades either.
Yes.
It sounds like you're doing it the right way.
Yeah. I have a few that are just still struggling. So they try to do their own way. And I'm like, please don't do it that way.
Mhm.
because
Yeah,
you're very far off.
Yeah. What
Well,
is
we're showing you it this way because it works.
Yes.
yeah. Trust me. And I know you want them to use their own strategy, but sometimes they're building incorrect habits and
Yes.
it's even harder to break them.
Mm-hmm.
I also feel like a struggle is for like I feel like this could be universal. It's like building that trust with students because like they just basically they have to trust that you know what you're telling them
Mhm.
is right.
Yeah.
And also like
Well, I
trust
also
the
feel like
process.
students can know like if you're not confident in what you're teaching them.
Oh yeah.
If you're not confident, they won't be confident in it.
Right.
100%.
You can just let them know, hey, there's a reason to the progression of why we teach it this way. And eventually, have you taught them standard algorithm yet?
I have. We just tested on it on Friday.
Where do you see the disconnect for those that aren't getting it? Is it the fact it's so multi-step and repeated?
Yes, I think that's it. She would even like, I don't know, her number sense is like high, but I
Mhm.
think it's hard for her to put it on paper.
Mhm.
Because even with multiplication, she would tell me what she was doing, and she was like almost all the way there, but not quite. Like, say she's multiplying 2-digit by 2-digit, she would show the multiplication of like halfway. Like it was that second digit that wasn't getting multiplied or
Mhm.
something like that. So when we went to division, if the number, I noticed for some reason, the smaller numbers, if it went in there exactly, she could get it. But if it wasn't exact, if it had a remainder, she was completely lost.
Hmm. But she's okay with multiplication, or it was hard for her as well?
It was hard for her
I
as
was
well.
gonna say if she's a strength in multiplication, she could just teach her to check her answer. If you think that's the quotient, then
Mhm.
try multiplying the quotient times the number of groups and see if you get back to your original. Yeah, your divisor. See if you get back to what is the one underneath it called? The dividend.
Yes.
You know, kind of use the reverse to check
Mhm.
your answers. Or a good thing is like reasonableness of answer. So, like, say she's way off. So if you're figuring out how many, I don't know, 12s are in like 1,000 something, whatever,
Yeah.
then have her relate it to, okay, use some mental math numbers. So 12 is close to 10. How many tens would be in that number? Like,
Yes.
you know, those estimation and rounding and reasonableness of answers kind of strategies can help a kid go, oh, I was way off, or yeah, I'm in the right ballpark, and then can look back and see maybe where they got off. But sometimes they just need more practice. I mean, y'all are just moving through so fast.
Yes,
Your
we've
curriculum.
covered so much already.
Yeah.
Mhm.
Like
And
it stresses me out to think about how quickly you're going through some of the stuff.
yeah, like multiplication, we did it in a week, and division, we spent a week on it.
Yeah, that's way too fast.
Yes.
I mean, it's still pretty fast. Like we're gonna do measurement in 2 weeks, and God, it takes forever to understand measurement. But because it piggybacks on powers of 10, I think it's gonna be easier, especially when we get to the metric measurements.
Mhm.
But I think when we do multiplication and division, it's 2 weeks and 2 weeks, and I think it's more feasible in a 2-week block than it is 1 week.
Yes, I 100% agree. Because
Because
it started with estimation, then we went straight into actually solving it, and I was like, "Ooh."
man,
I was gonna say estimate. I don't know why they do that, like with the estimation thing, because it's like, so now you actually have to have the exact answer.
Yes. And I think that kind of helps with like just trying to find the right roundabout answer, but it's hard because sometimes they estimate down much further than they have to.
Yeah, because like you have to teach them like to them what's close to them, you know, is not. It's like pretty far away from what you need them to be.
Yes. Like we could easily see 23,000 rounds to 24,000, but their minds it's like round all the way down to 20,000.
Yeah.
And then your answer's gonna be farther off than you really. It just depends how close you round is how close your estimate's going to be to the real answer.
Yes.
Yeah.
Okay. Question 3 is for each of the mathematical practices on the PDF where it discusses teachers and students' behavior. Did we all do that? It
Mhm.
kind of goes deeper into it. Take this opportunity to share what you highlighted that helped you get a better understanding of the expectations for teaching and learning these 8 mathematical practices. Do y'all want to just go through each one?
Yeah.
Yeah.
Okay.
If we have similar words or if something else stood out to each other.
Yeah.
For each one.
So,
Do y'all want to start on the side with the students?
The way I wrote it in my notes is I did make sense of problems and persevere in solving them. And then I wrote the teacher words, the student words, and then a summary under each one. So it was all
Okay, great. That's perfect. We can do that. So we'll start with the first one with teacher. Out beside it, I wrote just knowing the standard. And for me, it's like when to push them further and when to pull back, just knowing where they are at, and then showing different strategies. And I highlighted manipulatives because that is something I struggle with too.
yeah. I also highlight manipulative because that's just something that we constantly use. That's really one of the main things that we use in our classroom.
Mm-hmm.
So I feel like that's something I can, even though we use it a lot, that's still something I can, still work on instead of maybe there's different types of manipulatives that we can use that the students would, be more interested in using, or that would make sense for them.
Yeah.
One that stood out to me that you guys didn't put for, are we doing teacher or student?
Teacher.
Teacher was providing the problems, providing rich problems in appropriate time.
Yes.
And productive struggling.
Okay. Yes, I highlighted appropriate and productive struggling because sometimes I do jump in just like, okay, let's do this. Especially if I would keep getting the same question from multiple students. Like, okay.
Yeah.
On the other side, for student behavior, I tried to highlight most of the verbs.
Mm-hmm.
But the summary I said is making sense of problems in different ways and using trial and error to come up with those different ways of solving the problem.
Yeah, I highlighted exploring other paths, persevering, potential solution paths, reasonable answers, those kind of things.
Mm-hmm.
Yeah. I feel like it's that, they reason abstractly, and I feel like in my gut, it's hard to give them multiple ways to do something and be like, okay, now choose a way that's easier for you.
Yeah.
There's a lot of the students, the ones that have autism, they're very literal. So if you tell them to do something a certain way, they do it that one way, do exactly how you say it.
Yes.
And then you're telling them think abstractly and do it, whatever makes sense to you.
Mm-hmm. They're like, no, you show me how.
That's something I need to learn how to kind of adjust, it in a way for me to be able to do that, but without confusing them.
Yes. I feel you on that because sometimes I feel like we throw so much at them. They just are like, okay, I don't know which. I was that kid that needed to be told, okay, do this and then do this next and then do this next. But I know there's also people out there with more creative minds that like to think more flexible.
Yeah.
Those are the kids that are bored.
I really want to learn a way to kind of help my students kind of be able to do it a little bit in some type of way.
Yes. The second one, reason abstractly and quantitatively. I highlighted under teacher, variety of problems, different contexts, arriving at solution different ways, and then think aloud strategies and modeling those problem solving skills instead of just being like, okay, now you do it, but actually modeling those things. I really like this one because I wrote a lot out beside of it, and I'm not going to read all that.
The similar one stood out to me. Think aloud, the teacher side of things. Think aloud, modeling the problem solving. Listen for the strategies that the kids are using.
Yeah.
And then on the student side, I just put using symbols to represent situations. Does that just mean multiplication, addition.
Yeah.
Those symbols. Okay.
Using
Yeah.
And then
yeah.
just making sense of the problem, kind of like we were talking about earlier in word problems.
Mhm.
Word problems are a great one that fits well with this mathematical practice, being able to reason abstractly and then do the same thing with the numbers, quantitatively, is like with the numbers and with the operation, with the symbol.
Mhm. 3, construct viable arguments and critique reasoning of others. Explain, argue, and critique yourself and other students. And I just put out beside it, when we create strong arguments, we have to know the curriculum and what we're talking about more so we can support our ideas.
Mhm.
So this one's a lot where that mathematical discourse comes in place. So I chose a lot of verbs on the teacher side, discourse, explain, argue, critique. And on the student side, making and testing conjectures, and conjectures is pretty much means opinions. So state their opinion and be able to test others' opinions and listen to others and how they solved it. Ask questions about if they need to like further understand how someone else solved it, because it may be confusing to them. So being able to like pose as a student, like pose questions of how did you get there? How why were you thinking of it in that way? Be okay with identifying if someone does something wrong. And so that's a big part of like that classroom community, so that kids can discuss those things and not hurt each other's feelings, not be mean about it. Like, you got that wrong, but being like, I think I could see how you got that, but did you think to do it this way? Or I think this is where you messed up. This is how I would have done it. Or, can you find where you got it wrong, or, what went wrong there? So being able to help each other, critique each other, but not be mean. And that's hard in 5th grade.
It's funny though, because like in my class, my students are very like, like if you did something wrong, they'll tell you. So like they'll even tell each other, and sometimes it sounds mean, but they're just like being just straight up like telling you. But then like if someone's doing some like gets it right, they're like they celebrate it like it's the biggest like accomplishment in the world. Like they get so like they're so proud of them.
That's great. I was going to ask how.
It's so sweet to see it, but then like.
Yeah, yours are very, if they're on the spectrum, they're probably very straightforward. Like,
Either this or this.
You should have done this, yeah. But then they're also sweet kids on the spectrum, and especially Downs kids. So I could see them be really excited when somebody does a really good job. But are they able to, because they're not super the best at verbalization. So like, how well can they turn and talk to each other about things? Because I use turn and talk a ton in my class.
The ones with autism, they talk because like they each other. Ones that we have that have Down syndrome say like one word. Like if you can ask them a question, it has to be like one word answers.
Okay.
Yeah.
And then I'm trying to think, and then one of them will just say random words. Like he just doesn't really talk that much.
Mm-hmm. So you guys do the best you can.
Yeah, and then and because we have 2 kids that are in wheelchairs that they are nonverbal.
Yeah.
Like one that has cerebral palsy, but he still knows how to do the stuff. Like he'll point, like we'll have him point, and
I mean that's communication if you think about it. I mean that's his way of being able to communicate. It's and think about someone is deaf. I mean there's ways to communicate that aren't just, and so that's going to look different for every group. That's why I was curious how it looked in y'all's classroom.
Because the one that has, because we have a communication board, but like we'll do stuff on our whiteboard, like the touch screen, and so like we'll bring the kids that are in the wheelchair, we'll bring them up and let them do it too, because they can still like point to the board or like touch the board and do it.
Yeah, that's cool.
And they get you can tell like they just look so happy like when they do get it.
Yeah, they're involved. They're like, yay, I'm part of the classroom, even though they can't.
Yeah.
Not done in a verbal way. Yeah.
Mm-hmm.
That's one that I even put out beside it. I was like, I need to work on this, giving them more opportunities to share their thoughts and opinions. Number 4, really just connecting with their real life. So those word problems, so the math makes sense. So it's not just some abstract thing that we're doing that they're not ever going to do again, but actually connecting it to their life.
That's probably why your success for the week, Livy, was when they got to make their own word problems.
Yes, that is true.
It's their interest. They could make it real life based on whatever they wanted happening, and yeah.
Yes.
I had the same words: connect to student interest, real life context, the teacher side of things.
Number 5, just using appropriate tools and strategies correctly. When we were talking about division, I think it was interesting that you were talking about how if you just jump straight into the standard algorithm, they don't really connect the years past. And I feel like that would be a tool and just showing that, hey, this might not be the most efficient way yet, but we're going to do it this way so you see those overlapping concepts.
The connections. Yeah, it says strategically, which is a big part of it. So once kids know all the different tools, which when I put in my summary, I was like, tools could be technology. Sometimes we have technology-based tools, drawings, models, and manipulatives. Sometimes it's just scratch paper, whiteboard, like working it out however it may be, and then choosing your most efficient tool. I've still got some kids, instead of using multiplication to get to answers quickly, they're still using repeated addition. And I'm like, okay, I mean, I get that as a strategy to get there, but strategically, like, we're not going to get to the answer quickly if you're still using that tool.
Yes. Hannah, how do you use tools in your, you kind of talked about the blocks and the building blocks, but
yeah.
Hands on.
Like, or sometimes like a lot of stuff will be like, okay, like you have 2 apples and then you want to we'll try to like connect it to like their life, or like last time like one kid in our class, like he loves garbage trucks, so then we'll use like garbage trucks as like the example problem. You know? So like, we'll be like, there's like 10 garbage trucks, and then like you add 5 more. Like, how many are there? And he gets so excited because it's like he just hears garbage trucks, but like he's so excited to be able to do that. He's like, oh yeah,
because he likes that topic. He's like, yeah, I'll do math related to garbage trucks all day. Yeah. I like that.
Yes. Number 6, just attending to precision, explicitly teaching math vocabulary. Do a terrible job at that. I kind of move on.
I've got a great strategy on this. So I went to, since we last spoke, I said I was going to this Pioneer RESA training with the famous Graham Fletcher, and he's amazing. And it was so engaging and awesome. So a big thing with academic vocabulary, kids don't want you sitting up there and being like, this is called the blank. This is called the blank. And it's good to have a math word wall up and everything. But like, if a kid, say they're doing long division, Livy, and they end up saying, it's rare that they use the word quotient, divisor, dividend, because a lot of times they forget. So if the kid's like, well, the number of groups is 6, and you're like, yeah, you're right, the dividend is 6. I mean, the divisor is 6.
Yes.
So you reiterate the words they're using, and you just interchangeably use that mathematical vocabulary. So they might say groups, and you're like, yeah, the divisor. And then they might start using divisor, and you'd be like, yeah, you're right, the groups. So when they hear it, both kid version of it and the academic mathematical vocabulary of it interchangeably, it's just, it clicks in their brain better than you being up there and be like, this is called the blank, and then let's all use that word. You use them interchangeably so that like they hear them both ways. And it just becomes more natural for them to use both ways, the more slang terminology and then the more mathematical terminology. I know when he was talking about that, I was like, that makes sense. Then you're like validating the things they have to say, but they're exposing them to hearing the correct vocabulary, and you'll start to hear them use it, the words, I think, more often if you model it both ways.
Okay. Yeah, that does make sense, because my kids call their skip counts like multiples. Like multiples are the actual name, but they call them skip counts. So I have been using those interchangeably. Okay.
Yeah.
Okay.
Number
7 was okay. Look for and make use of structure.
Yeah.
I like this one. There are so many patterns in math that we don't think to connect to previous understandings for kids. But when you can connect to things that they already know, like we were looking at, it was like 25 hundredths in a decimal form. So 0.25 of a liter. And so I was like, okay, well, what, remind me what the fraction of 25 hundredths is. And they're like, oh, it's 25 over 100. And so we, looking at it as that. And then I was like, does anybody see any connection to another fraction there? And blank stares. And I'm trying to get them to say 1/4, 1/4 is the
Yeah.
same as 25 hundredths, right? So then I relate it
Yeah.
back to money because I'm like, you use quarters all the time. How many quarters are in a dollar? So they don't, some kids see patterns beautifully and connections between different concepts, but being able to model and help them bridge those connections, you just have to be aware of where these patterns show up in math. And so that you can take those opportunities to say, do you see how that connects to this? Because a lot of math is connected.
Yes. I think those are like big light bulb moments when the kids start to see those things too, because ours was we divided by 25 one day, and I was like, what else is 25? And they told me quarters. And then I tried to show them when you're dividing by 15, you could look like at a clock.
That's good too. Yeah.
Some of them got it, others were like, we don't know how to read that kind of clock. I was like, okay, never mind.
They always claim that. Ooh, it's because they can or they have been taught it, but digital is so around them so much more than an analog clock that
Yes.
for sure.
Yeah, like our kids, they learned about the time, learn time, like how to read time. Well, I think it was last couple weeks ago. And so now, like when we tell them, when they ask us, like, oh, when's lunch, and we'll say 11 a.m. 11. And so now they'll tell us like, oh, 2 more minutes.
That's
Or
good.
whatever.
Yeah.
Yeah.
Well, it's nice when they apply it. Yeah.
Mhm.
Yeah, so it's nice that they're able to use that.
And then the last one's very similar. Look for and express regularity. Okay.
Regularity.
Yes.
Weird. You got it, girl.
And repeated reasoning. This is why I like this math class so much more than the other class, because reading just does not click for me. But I just said, sense making experiences for all students was the main one there, and show them that, like, okay, you might not understand it this way, but let's look at this way and see if they understand it like that.
Yeah.
And you are right. 7 and 8 are very similar. Shortcuts stood out for me in both the teacher and the student vocabulary because they are similar. It talks about patterns, talks about observations and shortcuts.
Yeah.
One of the things I love about using the state unit and the Graham Fletcher three-act tasks, and he's not the one who invented 3-act tasks. I don't think. If you look up online 3-act tasks, it all starts with they see some kind of picture or something, and it's just sit there and tell me what you see, what you observe. And then questions you have about it. So getting them to just think for themselves. They all these things start with what do you wonder? What do you see? And that reminds me too of some of those instructional strategies from the classes over the summer where they talked about like which one doesn't belong, like all those kind of things. It just really gets kids to think for themselves. And it was real awkward at first, the first couple times we did it, because it was, even if it was just like, I see blocks. Or like literally is just telling me what they physically say, you still are taking, writing it on the board. Okay, you're observing this. And so now they're observing a little bit more in depth. Like what do you wonder? What do you, what do you notice? What do you wonder? This week had the digits 8 and 2 in different place values. So it was like 8,200. Then it was 820. Then it was 82. Then it was 8.2. Then it was 0.8.2. But they got right to it. They're like, it's the same 2 digits. They're in different place value spots. They're shifting to the left. I mean, like all the things they were talking about, I was like, it was exactly what I wanted them to get to. And then we had a whole little side conversation on what's a digit? And they could not tell me. They're like, numbers? I'm like, yeah, but what numbers? They're like, I don't know. They're numbers. And I was like, okay, well, digits are only one. They're in one space, 0 through 9. So why do we have 10? Because it's made up of 2 digits, 1 and 0. So we had a little side conversation on just like that mathematical vocabulary of what is a digit. Because I was like, even by 5th grade, sometimes it's good to just take the opportunities to make sure they understand that, because they had said this has the same numbers, 8 and 2. And I was like, oh yeah, the digits 8 and 2. But wait, what are digits? And we had that whole side conversation. But that was a good example of that notice and wonder. It was them noticing the patterns and structures and everything for themselves. And it was to get them to talk about what changes a digit's place and its value. And that leads to like powers of 10 dividing by powers of 10, multiplying by powers of 10, and that shifting of the place value.
I do like that. Honestly, when you
Yeah.
asked about digits, I was like, what are digits?
Yeah, 0 through
And
9.
you're like, wait a minute.
The 22 has 2 digits, 2 and 3. Yeah, 2 is in the 10. It's all about like what place they're in. So then I started using the verbiage, and I was like, I had them had a place value chart, and I was like, okay, I need you to put the digit 9 in the thousands place, and I need you to put the digit, like when you get to powers of 10, this is great, Livy.
Mhm.
So having them manipulate that and say, okay, well now I need my 9's value to be 1/10 of that 9 you just put. So they put it in the thousands place because that's where you told them to put the digit 9 in the thousands place, and they can do that. Most can.
Yes.
A few might not remember what each place is called. But if it's already on a mat and labeled for them, then anyone can participate, even your special needs kids. And then you say 1/10 of that value. So are we getting bigger or smaller? And they know bigger goes left and they know smaller goes right on a place value chart, but they can kind of manipulate with that. And then you're using that verbiage digit.
Yeah.
But it is interesting. It's kind of like puts their brains, because they were like on the right track. They're like, numbers? And I'm like, yeah, but what numbers? So that was cool.
Yeah, I do like that. I need to look him up because I need to start doing something like almost a review or just different things before we start math, instead of just like they have a review right now, but just something
More fun.
easy.
Yeah.
It's more fun. Yes.
And anyone can do it. Like, what are you going to say? That you noticed something weird in the picture? You can't get it wrong. Like
Yes.
every kid, and it builds that mathematical discourse of like every kid isn't scared to say what they see, and what you wonder is literally any question you have. It might even be, there's a really cool one, and I think I told you to look it up. The 3-act task by Graham Fletcher is gfletchy.com. He's got all these
Yes.
different 3-act tasks for each different grade levels, and they all have a video. And so when I went to his training thing, the video we watched was this guy it was like a timer in the background, and he was clapping, and he had this rhythm and this way of clapping. I think he ended up, what the video was a guy trying to beat a world record for fastest claps in a minute. And so the questions were literally like, why is the guy clapping that way? Is he trying to beat a record? Like, you could ask anything about it. How does he do it that way? Why? I mean, it was the craziest thing, the way he was clapping. But it came down to, mathematically, you had to figure out, if you're trying to figure out how many he did in a minute, then using long division, figure out how many he does in 10 seconds. And multiplication, like you're using all these to get to finding the actual answer of it. But like what do you notice? What do you wonder? Anyone can look at something and be like, yeah, I see that. And I wonder, why is he doing that? And then Graham was talking about, like, if a kid asks you a question and you don't know, you can totally make up an answer. And they're like, oh, okay, cool. They accept the lie you're telling them. That like fulfills that question they have.
Yes.
You don't know you're lying, and you're skipping past the things that really don't matter for the math, so that you can actually get to the math. You can just like totally make up, like, yeah, totally. This guy's from Ohio, and he had been working on this for like 3.5 years. Like, we asked these questions and he said this stuff, and we were like, oh, cool. And he's like, I totally just lied to you. I have no idea how long he's been practicing this clapping technique. But because you just say it confidently, it gets that wonder out of their head and gets them back on the point of, why am I even showing him this video? This guy clapping.
Yeah.
I like that.
Yeah.
Yeah.
All right. The next question, number 4. What mathematical practices do you currently implement consistently in your own classroom? I would say number 1, 1 and 2 pretty frequently, and number 4, I feel like we model almost every day with stuff on the board, like tape diagrams, and
That's good.
we're using those place value charts.
That's what I need to improve. It's my
Yeah.
model mathematics is what I put on my need to fix.
Yeah.
Yeah.
I feel like I use 4 and 5
Mhm.
a lot. A lot.
Yeah, you're just modeling.
And especially with the concrete models and just, pictures.
Mm-hmm.
Yeah.
Well, y'all's strengths are my weaknesses. That's good.
Mine is, yeah.
But that's why we have each other, because
That is right. I'm pushing
mine-
Yeah, so I guess we're a good group then.
mine was attend to precision, consistently modeling precise math vocabulary, encouraging students to do the same, and using that, like after Graham told me that I can use their slang, but like interchangeably, so that they eventually start using math vocabulary correctly. And then the construct viable arguments. We do a lot of turn and talk, a lot of partner discussion, group discussion. And I think it's just because of what I'm using this year. I don't think I always had my kids, and other subjects. Yeah, I've always been great about class conversations, turn it talks, partner, those kind of things. But doing it more in math has gotten a lot better this year for me.
Yeah. Those are my 2 weaknesses.
Look at
Well,
that.
number 7 with the patterns, and then number 6, precision. Getting them to actually write out like their units, I
Oh yeah.
struggle with that. And then the vocabulary, like we talked about, and then turn and talks, we rarely do that.
Yeah. I was gonna say we don't do turn and talks like at all.
And it because a lot of you, Hannah, you're working with them more one-on-one. They can tell you. Just get them to tell, get them in some way.
Yeah, so that's what we do like a lot, like is one-on-one with them, which is actually really nice in a way, like because then like I can really see like what each student needs help with or like what they're really strong in.
Yeah, I would love to be able to work with my kids more one-on-one. I feel like
we only have like 12 kids, so it's a lot easier to do it that way compared to having like 27 kids.
Yeah.
Like you don't have the benefit of time to be able to talk to every single one of your students.
Right. Yeah, I try to listen into their conversations, make sure they're on topic too, as they have a bunch of different kids going. And then I'll like point out, be like, you had a great thing. Can you save that for the class? I love what you guys just said. Can you save that thought for the class? And then have them share out to everyone. And that kind of can redirect the thinking if kids are on the wrong track of what they're talking about. So I feel like kids are really good at talking in my class. My weakness that I don't implement so much is persevering when solving problems. So I want my students to be okay with this productive struggle, being confused, challenged. That's really been like you got to let this happen this year, especially if I'm using the state units because they're hard and they're going to struggle and it's okay. And not be so quick to give up and just provide the answer how to get there. Also having to use these state provided test banks, like being okay with my kids failing, like that kid just did not get it. They're going to adapt to the rigor. I know they are. It's just so hard to see someone, literally failing. But we've had a lot of conversations because I saw like the disheartened faces when they got those tests back. When we went back over them, we talked about what about them made them harder, which ones were more difficult. And just talked about, pushing through and keep doing our best. And I mean, I know they've been doing their best, and it's going to come easier to them when they continue to see the deeper thinking kind of questions. It's not just having them solve. I mean, because I also gave a quiz a week or two prior to see if they understood volume, and it was just the shape and length, width, and height, and they all passed. They all got A's and B's. So they all understood the basic of the concept. They just didn't. And that's why you see, like, you think your kids are getting it, and then you see get their milestone scores back from the previous year, and you're like, why are half my class 2s when I feel like they were all 3s that get in class? It's because of the in-depthness of the milestones. So I do think at the end of this more difficult year, the kids are going to be better prepared for the milestones.
I feel like there's only so much, because I feel like there's only so much you can do to prepare them for it too. So I feel like that's also like a struggle for y'all.
Yeah. And then we're judged on how well the kids do. At least I, take it very personally if my kids don't do great on milestones. And it's fine. Like some kids are going to always be a 2 or a 1. I mean, I teach a lot of special needs kids, but like we just got our scores back from last year. And what stood out to me was high growth, average growth, low growth. I hate the ones that say low growth. So they're comparing their 4th grade score to their 5th grade score. And maybe it was still a 1 or still a 2, but it goes a bit more into detail of, did they adequately grow what you'd expect a kid to? Did they have high growth? Did they have low growth? Even if a kid isn't amazing, I want to see adequate average to high growth. The low growth makes me feel like I didn't do what I should for them as a teacher.
So this is a little bit off topic, but you could have a kid fail, quote unquote, 5th grade, but if their milestone scores are like a 3, 4, do they still get passed?
Because the likelihood of someone in 5th grade in general being held back is very
slim.
Yeah. So because of, I'm assuming back to the No Child Left Behind Act, is the most common grades to be held back are going to be under 3rd grade. So if a kid fails, It's very rare, I feel like, to see a kid you mean like failing within the report cards, but then somehow pass the milestones?
Yes. Like,
Yeah,
if you truly didn't curve those tests,
right.
do you
Yeah.
think you would have, like, multiple fail and then do hopefully well?
I feel like I see it
Taking
pretty
this.
similarly in the classroom. Like if they're failing in my class, they're most likely a 1 or 2 on the
Okay.
milestones, and I've never seen where I've got one. And if it is, it's either responsibility, not turning in
Mhm.
assignments, rushing through assignments, silly mistakes, effort.
Yeah.
And then the day of the milestones, they all of a sudden decide to really try, and you're like, wow, you could all year. I had a kid like that last year. It was one of my girls, one of my really difficult girls. I was like, I literally did no justice for you all year. You did horrible. I looked at her scores and she had high growth in both areas. I was like, day of milestones or the week of milestones, you cared, but all year you wasn't. So it really suggested to me, but like Libby knows the child I'm talking about. So like it makes sense. Her focus was so much on friendship and boys and how she looked and fiddling, and she also had ADHD. So super bad focusing,
Yeah.
but day of milestones, she showed high growth in both of them. And I was like, oh, okay, interesting.
Yeah. Like as someone like it's also sad, like 'cause some kids don't do good on milestones, but then you see in the classroom like they're so smart, they're doing so good, and then you get those
Yeah.
scores back in the test, and you're like, what happened?
Yeah.
I also feel like it's because some students personally, like I'm not a good test taker, so I feel like a lot of times it's because they just get nervous
Oh
and they
yeah.
just
Some
freeze
people are
almost.
just, yeah. Some people are just not good test takers. They're just not.
Because like I'm not a good test taker, so then once I was able to not like once I got to a portion of college where we didn't have to take tests anymore and it was just assignments, I was doing awesome. Like it was a lot easier for me because it's like I was actually applying what I knew instead of just memorizing.
Mm-hmm.
There's a big difference there.
And then also when it comes to grading, Graham was talking about this, not always grading the outcome, but the process. So sitting down with a kid
Yeah.
and doing those like formative assessments of watching them as they do things. It's kind of hard to like put that quantitatively in a number and to then put into your grade book, but grading and not so much the outcome being like the summative, the test, the physical test, but how they did with the concept in an informal way. Those informal observations. Kids. It's just figuring out, okay, how do I put that into a number score,
Yeah, like because I had a math like one of my professors like math like he would like if you wrote out like how you did a problem he would give you points for just writing it out even if you got the answers wrong if you wrote it out how you the process
Mhm.
he would give you points which I actually like really look up to and like I like that because it's like you're giving me credit because I did it correctly I just got the wrong answer.
Right.
Yeah.
I always give half credit. If I can see their thinking on a test and I see where they went wrong, like with this volume test we got, one of my girls is really low and she did really well on it. For one of them, they knew that the base of this fish tank was a 4x3. So they knew that the area of the base of this fish tank was going to be 12. And then they said, could she go to the store and get a tank that held 36 gallons? So the thought was, is 36 could 36 have a base of 12? Meaning, is 12 a multiple of 36? And so she showed it off. She's like, 12 plus 12 is 24, plus 12 is 38. So she answered no. And I was like, oh, okay, so she had the right idea, adding by 12, try to get to 36, but because it didn't, because her adding was slightly off, she wrote no, he couldn't use that stand. So I still gave her half credit because I was like, the fact she knew to go by 12 to see if it would work was what I was trying to test for.
Yeah.
So I'm glad that you've had teachers before, Hannah, that have done that. You just have to, if a kid doesn't show their work, that's when you're like, well, you're out of luck because I don't know how you got there. So show me something, please, so I can see if I can even give you partial credit.
Because a lot of times I'll be like, hey, I can't help you if you don't if I don't know how you got there.
Right.
Yes. And I've even noticed I try to give as much credit as possible. So I tell them to write it out. And there was this one boy that would just like write numbers. It seemed like to me. But then when I asked him, like, where did you get these numbers? He could explain it to me. So sometimes I'm like, I wish you were right here beside me when I'm grading this because what you're telling me actually is making sense. You're on the right track. But based on how this looks, it looks like you're clueless.
So those observation notes are really helpful. You just have to think of how are you going to take that and possibly curve his test grade, plus this many bonus points due to classroom observation or like something.
Yes.
And just be ready to defend why, if someone were to ask, why did the child get extra points when they technically failed the test?
Yeah.
Yeah.
The next question is, what would you like to implement into your classroom? Which one of the mathematical practices? I put the one where you're using manipulatives, and then communicating that language, just being clear and concise with my language. I feel like sometimes I get too wordy or I'm not wordy enough, so they're just like kind of staring at me.
Mm-hmm.
The blank stares are real.
Mm-hmm.
I'm like, okay, I have no idea if y'all are getting this or not.
I would say for me, like, attend to precision, like making sure I'm using like clear language and like accurate, like, because I have to be careful with what I say because they do take it literally. So it's like, okay, let me think of the wording that I'm going to be using when I tell them this. Like,
yes.
So I have a great example of that, Hannah, and bounce off of you. So I'm more aware of it now, but I think it's just because I've been teaching for quite a while. But we're used to hearing and like speaking out how we would solve it. But sometimes if we say just slightly wrong, it throws off their understanding. So an example of that was when we were talking about powers of 10, we said 10 to the power of 3. And one of my kids, oh, so that's 3 10s. And I was like, oh, if you say 3 10s, I'm thinking 10 plus 10 plus 10. I said, well, so what do we mean by 3 10s? I mean 10 times 10 times 10. Another thing with when you're multiplying by powers of 10 or times 10 or times 100, anything like that, when younger grades, and you do it again with powers of 10 in 5th grade, is saying, okay, well, don't forget to add a 0 to the end of your number. Add a 0. If you add 0 to anything, it keeps the value exactly the same. Another thing Graham Fletcher brought up was when you're teaching equivalent fractions and finding common denominators, you'll tell them, okay, well, just multiply whatever digit you choose to multiply the numerator by, you do the same to the denominator. And so they're just following that formula of, okay, well, that's how I find an equivalent fraction. I times by 3 to the numerator, so I got to times by 3 to the denominator. And I've done this, I don't know when it clicked for me why, but once I explained it to my kids of why, so we backed it up to the identity property that you learn in 3rd grade is anything times 1 is itself. So if I'm trying to make an equivalent fraction, I need it to equal itself. So I'm going to multiply it by 3 in the numerator and 3 in the denominator because 3 over 3 is 1. So when I'm making equivalent fractions, I'm really just multiplying by 1, but in the form of that's equal to 1 whole. So when you word it as like, that's why we do that strategy, it just, I don't know. I've just seen a lot of things like light bulbs go off because they're like, that's why I multiply it by that.
Yeah.
And what was another thing? It'll come to me probably later. Oh, this stood out to me too when it comes to fractions. So Graham asked us to turn and talk about what a unit fraction was. And a lot of teachers would say different fractions. And I remember because I taught 3rd grade, a unit fraction has to have 1 as a numerator. So your unit fraction will always be one piece of whole. So it's 1/8 or 1/6. So when you get to manipulating and working with fractions in 4th and 5th grade, if you want a kid to add 2 different fractions together or work with numbers that are larger than 1 whole but are still related to fractions, you're going into your mixed numbers and improper fractions and whatnot. If you use the verbiage of 3, instead of saying 3/4, saying 3 1/4, they can take that 3/4 and break it into 1/4, 1/4, and 1/4. So when they're working with fractions, they don't see it as just, I don't know. It's something about that wording of saying, or so it's like 7/8, you'd say 7 1/8. And they might be like, why? What makes 7/8? 1/8 7 times. So then when you're working with multiplication of fractions, division of fractions, adding and subtracting fractions, they can do so much more with it if they can decompose fractions, because they decompose numbers all the time in younger grades, like whole numbers. But something about fractions all of a sudden switches in their mind to something that's not as hands-on and physical as when they were younger. And I said something about there's some power of that, especially if you're going to eventually get to fractions that are greater than a whole, that kids can just manipulate in their mind fractions better if they hear that wording. And that one, like, again, blew my mind. I was like, that totally makes sense.
Yeah, because like what makes sense in our head probably doesn't make sense to like them. Like the way I explain stuff,
Mhm.
it makes sense to me, but then like it may not make sense to other people or other kids.
So like if you're using getting to be greater than a whole, or they're adding mixed numbers, if you've got 7/8 or 7/1/8 plus 5/1/8, they can go, okay, well, 7/8 is only 1/1/8 away from a whole. So I'm just going to borrow 1 from my 5/8 and I'm going to make my whole.
Yeah.
And then I'm left with 4. What did I say? 5? I said what? 7/8 and 4/8. So then,
Yeah.
so then they just can move fractions around a lot better the way they could do it if you were to say, okay, add 9 plus 7. Well, what's the strategy with 9 plus 7? Make a 10. Take 1 from the 7, make the 9 a 10. And that's what they do when they're little. And so if you can do the same thing with fractions, it just, again, it's that patterns in numerical reasoning that goes back to the younger grades. And so there's similar strategies that they were really good with whole numbers, and they go to fractions and it's like, not there anymore because they see fractions.
Yeah, they're like
I just had to share. There's so many cool things he talked about, and that I can't think of everything. It was the one
I'll have to look them up.
Yeah, the one that I went to was on fractions specifically.
Okay.
Talked about how important it is the way you teach fractions to third, fourth, and fifth graders, and how that either helps a kid be successful in middle school or totally screws them up, because they do end up doing so much more, and then they'll go to ratios, percents, proportions, all those things as they go into middle school, and so preparing them to be successful. And he just talked about, these are the things that most teachers do wrong, that you just don't know better, and then you're setting your kids up for failure as they get older. But we're not meaning to. It's just and I'll email you guys a website of his. He's got these really cool progressions of it's kind of nice to know like what they learn in the grades before you. And what then comes after you, so you can see the connections, even though you're only required to teach them your standards. I'm very grateful that I've taught third and fourth, so I have experience with what comes before and after. But if you're newer to teaching, you don't have, and you might stay in this grade level for a while. So if you look them up on, I can email them you guys, or you can look them up. But Graham Fletcher Math Progressions, he has a progression on how addition and subtraction builds from kindergarten up, progression of multiplication, progression of early counting and numeracy, progression of fractions, subtraction with regrouping. I mean, he has these progression videos that are really interesting to watch. And they're not very long, they're like 5 minutes each. So like before progression of base 10 models and how that connects to the upper grades. He just kind of shows you in a nutshell, because I'm a visual and auditory learner. So when I can read about progressions, and the Georgia DOE has these ways to show you, hey, these are the progressions of how this builds on this. But he just puts it in a video that makes it make a lot more sense.
I'm so glad you used that fraction one, because we're teaching fractions next week.
Yeah.
And yeah, that's going to be helpful. Because I remember just learning about fractions and how hard it was for no reason.
Yeah, because I don't know, they see it abstractly.
Did everybody get to talk with that one? I think so. Yeah.
I talked about mine's the productive struggling.
Yes.
Trying to make myself more comfortable with it.
That's something that I've struggled with too. Number 6 is really just diving into our grade specific mathematical practices. Okay, this is my first question. I actually typed this out. Sarah, how do you know when the problem is too hard?
How do we know when it's too hard? Like what we're giving them is more than they can handle?
Yeah, or let them struggle.
You'll usually know it's too hard if all of them are staring at you like, what are you even asking me? Then you find a way to reword it.
Yes.
And hope that that clarified something. And then sometimes I throw them a bone. Like, this is what I would do to start. I would, if it's like long division, I would use my estimation strategy. I would say that number on the outside. My dividend, no, that's on the inside. Divisor is 25. Well, I know how to count by quarters. Like, everybody turn and talk real quick. How much money is 5 quarters? And they'll talk 5 quarters is $1.25. So 25 5 times is 125. Okay, so since that divisor is close to that number, I'm going to make an estimation of it. And then I don't know, just give them something to get started with. And sometimes it just barely sparks something in their mind to keep going. Or do one together and then give one. Now that you've seen how I would work through this more difficult problem, let me give you one for you to work with at your table. And it's just as hard, but kind of think through. So modeling without giving them an answer, and then give them the chance to try one just as hard by themselves. Is what I would say with the how do you know if it's too hard kind of a question.
I'm so glad you teach 5th grade too. So now we can talk.
Yeah.
And then you can relate to Hannah because you've taught all the grades.
Sweet special needs
It's
baby.
just also a nice note because then, like, okay, there's someone that knows that knows more about what they're doing. I'm like, okay, I can get some advice on this, how to do this certain things.
That's something that Dr. Chang put on one of her things. She's like, most of the girls in the program are new to teaching, so it'll be interesting to see what things you can glean from the mistakes I've made and how I can say, don't do that. I'm finding mistakes that I do all the time, and I'm like, why did I do that? When I went to that grandfather thing about fractions, I was like, dang, I was so bad. Keep, change, flip, and then he was like, okay, you have to because we're about to go into, no, we're not about to. I was in that math thing on Friday, and so I'd paced out the rest of the school year for hours. While my brain's like, what are we doing next? I don't remember because I know what I'm doing the rest of the year. But when we get to finding common denominators and adding and subtracting fractions and comparing fractions, he like put these ones on the board, and as adults, he was like, and you can't use the butterfly method, and you can't use this, and you can't make a common denominator, but you have to add the 2 fractions. And I was like, what? Like having to look at these fractions and manipulate them without all those strategies that I'm used to teaching and or using when I was little. It was interesting, but he like remade my brain think about fractions in a more interesting way. And then he had these like visuals of fractions, but it wasn't like the usual ways he would split and shade them in. I'll send you guys some stuff, especially you, Olivia, since you're doing 5th this year to fractions, because it was really cool. It was really cool, some of the things. But man, for him to be like, and I was like, I've always taught my kids just like, this is how it's solved. Just repeat the steps, but they don't understand the why. And then they can't do it without certain strategies. They can't really see it. I mean, we talked about like, I've always, when you compare fractions, instead of just using the butterfly method or the tricks to get it, relate it to benchmark fractions. Is that closer to 0? Is that closer to a half? Or is that closer to a whole? And then ordering fractions is easier at that point, or if you're doing comparing greater than less with fractions. So benchmark is one I've done, but I've also been really quick to just teach them the tricks. So
isn't there a way where I think we did this in like one of our math classes, Hannah, but you draw the box, and then if it was like 2/3, you would split it this way and color in 2. And then if it was adding, like, this might be multiplicate.
It's multiplying. If you're thinking,
you go the opposite way and you color those in, and then
the ones that overlap.
Yes,
is the answer. That's multiplying fractions. Yeah. So that's modeling. That's great with modeling with drawings.
Okay.
Yeah. And with making equivalent fractions like drawings and things. But yeah, if you're gonna talk about equivalent fractions, really relate it to why they multiply that numerator and denominator as the same number. That it's the same thing as multiplying a number by 1 whole, or the number 1, the identity property and everything. I feel like that's a big thing when they're doing that. So she said, like, share any questions you have regarding mathematical practices, but I didn't really have any questions. I just
I can't think of any, like,
no, and I even
off
said
the top of my head.
I just wrote out things that stood out to me. Let's see what my mind was thinking when I did this last weekend. I wrote, they may check their thinking by asking themselves, this stood out to me, that kids can check their thinking by asking themselves, what is the most efficient way to solve the problem? And then I made a note, kids do not always work efficiently, so I'm working towards modeling more of that this year. So that just stood out to me as having the kids go, am I being efficient with my time? And kind of showing them how to be more efficient. And then I made a note too when I'm doing anything with units to make sure I focus on the importance of units when you're doing perimeter versus area versus volume, converting measurements. Has a lot to do with units. That was a big one that's in 5th grade. I wrote refine their mathematical communication skills as they participate in mathematical discussions involving questions like, how did you get that? Why is that true? Kind of guides their explaining their thinking and their responding to others. If you give them like sentence stems and those kind of questionings to like, why did I do it that way? And then get them to talk about it. Using estimation as a tool is a big one I've been using this year and stood out as something that 5th graders have to do. Connect understanding of place value when working with multi-digit whole numbers, fraction, and decimal operations. So just connecting everything back to place value stood out to me too.
Yeah. I think it's interesting how you can also, like you said, check your thinking before. Does it make sense? But also check your thinking by undoing what you did. So like if you multiplied, then you can go back and divide to see if you got that.
First operation. Yeah.
And I've been trying to show that.
Really them understanding. I mean, it's just seeing those patterns.
Yes.
Once they connect all these concepts, they see everything as individually units they've learned from, and each year they see it as different. I'm like, everything builds. Yeah. And that's why those progression videos are so cool. And if the progression videos seem student friendly, it might not hurt to show them like, guys, this is how we connect what you learned about addition, subtraction from your younger grades up to what we use with them now. I'd have to look at the videos closer. I haven't looked at all of them if they are kid friendly, but for them to start making those connections of why you learned that in kindergarten and that in first and that in second and that in third, and how it all connects.
Yeah. Okay. Do y'all want to share your lessons?
Oh, yeah. Is that the last thing?
That's the last thing. And then just explain success, struggle, and what mathematical practices we use. Do one of y'all want to go first, or I can go first?
You can go ahead. I'm trying to find it.
Okay, great. So my lesson I did over solving the 2-step problems using multiplication and division, or multiplication and subtraction. And that just kind of shows, I said it connected to number 1, make sense of problems and persevere in solving them. Doing multiple steps, it did take a lot of persevering because sometimes they didn't do the first step right. So they would have to go back and redo it and restart. And some of my students were like, oh, I'm pretty sure they thought I was the worst that day, but oh well. Also reason abstractly, just understanding what they were actually learning. That's why I picked number 2. Like, does this make sense? Like, if I took this out of the context or put it into another context, would that answer actually make sense? Why would you divide first, or why would you multiply? Number 4, using a model, kind of showing, okay, total meant I have this much money, and showing that it had this much money, and then I divided it. And number 6, just attending to precision, and using that mathematical vocabulary. My success, I thought the overall the lessons went well. The problems, they were rich, they were hard, but not too hard. My second block, I did give them a little bit easier problems, or I would kind of show them, I would throw that bone because I saw, okay, my first block, this is where they struggled, so I could differentiate kind of, so they wouldn't have as much of those struggles. My struggles were, some of them still had no idea where I was getting those numbers from at the end of the lesson. And I kind of saw that on the test. It confused them, like, okay, now I'm going to do all of these word problems as 2 steps. And I'm like, okay, I know there's enough numbers to do that, but it's only a 1-step problem, like really understanding the concept behind that word problem. It's not the concept of actually multiplying now. It's the, okay, am I pulling the right numbers? All right. Yeah.
So you chose multiple practices to implement.
Yes, just because I didn't implement them all the way.
I got you.
Like, I just kind of pulled from each.
Yeah, she's like, use one you don't implement very often. I was like, I implement all of these. But
Yes.
which one am I the worst at?
And honestly, I looked at these last night, but I knew what we were doing and I kind of knew. So I was like, okay, this is what I did. So I worked backwards. Shouldn't have, but it's kicking my tail right now. So
It's fine.
Okay, so then I also did multiple ones just because work on too, just like here and there. But so I did the make sense of problems and persevere in solving them. So then the lesson I did, it was solving like simple like addition problems up to 20. So then for that one, I just broke each like problem into like smaller, like clear steps, and then like I modeled it using like manipulatives and like pictures and stuff like that. And then if students were like stuck and understanding it, I would understand one way to do it. I would encourage them to use like a different tool, like counting cubes or the number line.
Yeah, I do like number line.
And then I also did the construct like viable arguments and critique the reasoning of others. I just like modeled it like by using like sentence starters. By saying like I counted this many, or like I used the number line, so then they could share like how they solved that addition problem. And then I used used appropriate tools strategically, which like I gave students like multiple like a choice of tools that they could use, and then I let them decide what would help them the most. And then I feel like that really did kind of help them stay engaged, because like a lot of times when I use a number, like when I was teaching them the number line, they didn't, like a couple of them were like not engaged in it. So then when I finally used like the counting cubes strategy, like where I had them count out cubes, I saw that they were more engaged in that like way of teaching to them.
Which I feel like is, yeah, I could totally see that. Were they like snap cubes?
Yeah, they were snap cubes.
Connect to each other. And you're doing up to 20, right?
Yeah.
So say say the numbers I had to do were 9 plus 7. So with those cubes, having them make a 10, so already have the 9 separately and a 7 separately, and see the value of how it connects to place value. And have them physically connect the 9, and then you have this many more. Be like, well, how much? What's an easy number to count by? 10s, and then you take 1 from the pile of 7, clip it onto to your 9 there, and then you can see it as now place value, a 10 and 6 ones, so 16.
Yeah, because before like that, like when we did place value, we would take the blocks, be like, which one's more? Like we'll have one that has like 5, and then we'll have one that has like 7, and we'll say like, which one is taller?
Right.
Like which one has more? And then we would have them point to the one that has some more blocks, and then so they're already familiar with counting those cubes. So
yeah, because that counting up strategy. So if you're adding 2 numbers, put the one in your head that's already bigger, and then you just have to count up. You don't have to use you're making yourself, again, that working efficiently part. If you're starting with 5 in your head or on a number line or whatever it may be, and then counting up with a 7, you're already wasting time instead of using the larger of the 2 numbers to start with.
Yeah.
Okay. And then with mine, I feel like I talked about mine some. So I chose model with mathematics just because I was a lot better at it when I taught younger grades, but 5th grade, it's just a goal that I want to do a lot more this year. So my lesson was on place value understanding, introducing this was the introducing also. So it's like the first time we introduced the concept of powers of 10. And I tried to do it with place value blocks, but my gosh. Introducing the concept that a digit to the left is worth 10 times more than a digit to the right and vice versa. The main activity of the lesson was supposed to introduce students to multiplying and dividing by powers of 10. So students use their understanding of base 10 blocks and place value to represent tenths, hundredths, and thousandths with manipulatives and decimals. Each group was given a place value block to physically model and represent the relationship. Well, they were trying to figure out that there are 10 tenths in a whole, 10 hundredths in a tenth, 10 thousandths in a hundred, and a hundredth. And then that was the one that was a total failure. And then the next lesson had us move on to from that physical manipulative to using a place value chart, which is still modeling with mathematics. So I was like, okay, it made me feel better that it doesn't have to be necessarily with something in their hands. And so that we use the place value charts to make that connection that 10 times, it grows of each place. And then that places decrease by 10, dividing by 10 by each place. There were very few successes with the physical base 10 blocks being used as manipulatives. Even though I explained that the blocks should be used appropriately for math purposes, kids get fidgety and they end up building things they shouldn't or distract themselves and others. Also, the students were working 4 per table and they needed to share those blocks to work together with those manipulatives. And this was a struggle for students because like 1 or 2 of the 4 at each table would be efficiently working with the manipulatives, and the other 2 either wouldn't be engaged or involved or goofing off. So that was with the manipulatives for me. Another struggle was representing that thousand space cube and having them think of that representation more abstractly as this is just one whole. And now I'm working with decimals because decimals are smaller than one whole, and like what parts of that cube meant a tenth, a hundredth, and a thousandth. But it's just because they'd already had previous understanding and use of flats, rods, and cubes and thousand blocks. So then having to have them use that same thing but think into something less than a whole, into decimals, which is hard for them. In the future, I may try electronic. This is because it said like, how do you prevent this, like be more successful in the future? Or this is just where my brain went. I don't know. So in the future, I may try to use electronic based 10 blocks to minimize students goofing off. And that allows all students to have their hands on it. Like I just didn't have enough physical place value blocks for them all to do. So they had to work in groups. So I was like, well, I know of virtual based 10 blocks and that's still modeling and them still getting the conceptual understanding using the place value blocks, but it's electronic. So everyone can do it.
Electronically, can you change like the colors? It's like if you're just looking at 2 tenths.
There's different sites that have different ones, but I bet you there are some that you can manipulate and change the colors and things too. Also, I felt like I went into the lesson not really knowing how to explain it well. So I don't think I helped the understanding much either because I wasn't prepared to explain it the way I needed to. So I wrote, I'll be better prepared in the future to explain the connection of the blocks to decimals and have different ways of explaining in case kids are struggling with that understanding or have a lot of questions. And then some successes, the lesson with the place value blocks felt like a failure, but when we moved into modeling with mathematics using that place value chart, things went much better. There was better engagement and understanding for the students. Their conceptual understanding was strengthened using that type of modeling. So I was hoping the physical place value blocks would be better, but it ended up being better when we used the tool of the place value chart.
Yeah.
Because then it's more visual for them when they get to further with powers of 10 and y and all that. Oh, and then we related it. It was kind of cool. We had a really good discussion about the word Google is 10 to the power of 100. And so that's 1 with 100 zeros. So we talked about the efficiency of why do we even use exponents? And like, a million is what? 10 to the power of 6? Yeah, 6. Yeah. And so then we saw how big they could think of numbers. They're like, oh yeah, billion, billion, trillion. They got up to non-nillion. And I was like, how do you guys know that number? They're like, yeah, so it was just kind of cool to see why we use exponents, like the real life power that numbers get so large. Do you really want to write out that many zeros? And then we talked about the real reason we use decimals. It's things are smaller than a whole and they're getting more precise. So I was like, I could tell you guys I have $120 in my wallet, or I could tell you that I have $119.27. What's more accurate? The one that's my decimals. So we really talked about some real life context. We talked about real life jobs that use these things. We talked about in the medical field, they use a lot of decimals. Because if it's not precise amount of medication, what happens if you don't give the exact precise amount of medication? Someone could die. We talked about construction. If you're building something, if it is not down, again, using decimals, very precise things built together. Otherwise, things break, fall apart. bankers. We just talked about a lot of professions. It was kind of cool for them to see some reasoning behind, like, why am I teaching you this?
See, I like
There were some successes, but man, Monday, if you had asked me, I would have been like, I'm done. I'm done with the week. I'm done.
that.
Oh yeah.
My Monday was rough. I don't know
Same.
full moon or what, but I went home in such a bad mood, and luckily my
No, it was the moon. Anyone that says that full moons don't affect kids, they
no.
don't work with children.
And then one of my kids that is obstinate, defiant, and severe ADHD didn't take his meds that day, and so I had to get the principal to get him. I rarely kick a kid out of my room. I was like, get out of my room, and he was like, what? And I was like, I gave you a warning. You got laps. That didn't work. So then I warned you that you were gonna get silent lunch next. Then he got that. That didn't matter. So I was like, get out of my room. He's like, what? And I was like, I cannot teach. They cannot learn. Get out of my room. So yeah, my Monday.
He's like, wait, what? What do you mean?
Yeah, he's like, oh, I don't think you were mean like that. And I was like, I can't think. No one else can think because you won't stop making noises and talking. Bless. But
Yep.
he's
I
been
had
better
to
since
be
then,
that. I
so-
had to be like that yesterday. Oh my gosh, it was good because like my teacher is out of the classroom.
Yep.
She had meetings all day, like IUP meetings all day,
Yep.
and so it was just me and the other parapro.
Had to be a little bit more
Yeah.
harsh. Yep.
Fun times.
Yep.
My Monday was rough now that I think about it too.
The week got better, but Monday started off. Yeah, for sure. All right, Livy, did we get through everything?
Yep, that was the last one.
Cool.
Let me make sure I'm on a place value chart right now. When you were talking, I was playing with my place values.
Yeah.
Yep, that's it.
Cool.
Okay. I feel like that was shorter than the last one, but you know.
It's supposed to be closer to just an hour and a half. I don't think it was supposed to go up to 2 hours.
Yeah. We're good.
Stop recording.
Okay.